Hey, Bryn. Hi, Bryn. Okay. Welcome. There's 3 of you on. Brenna's the only one who told me she's on. So if you are on, please let me know. Okay. We're just going to jump right in. So this is just a lesson that is to better understand box plots. I need a pencil with lead. We'll try this one for a bit. Okay. Hopefully you checked your email and figured out what pages you need to do for your upcoming packet. If you did not get a packet, you need to let me know ASAP, as soon as possible, so I can let you know. I can drop it off to you. Okay, so why is it important to order the data before we find the median? Well, the median is the middle value, and therefore the data needs to go in order from least to greatest. So if you look at exercise 1, it says the Supreme Court is the highest court. Hey, Aiden, I haven't heard from you in a while. I'm dropping off your next packet. Hey, Layla. Aiden, I'm dropping off your packet after this. The Supreme Court is the highest court of law in the United States, and it makes decisions that affect the whole country. The Chief Justice is appointed to the court and is a justice the rest of life unless he resigns or becomes ill. Some people think that this means the Chief Justice serves for a very long time. The first Chief Justice was appointed in 1789. The table shows the years in office for each of the Chief Justices of the Supreme Court as of 2013. So we have John Jay. He was a Supreme Court Justice for 6 years, and he was appointed in 1789. And then you have John Rutledge, 1 year, and he was appointed in 1795, and so forth, okay? So I'm down at this part, on the A part. So use the table. Use the table to answer the following questions. Which Chief Justice served the longest term? And which served the shortest term? How many years did each of the Chief Justice serve? So first, let's see who served the longest. So we're going to look at the table, and these are the years that they served. So we're going to see which one was the longest or most years. So I see 34. Is there any that have more than 34? So John Marshall served the longest term. So I wrote John Marshall served the longest term of 34 years. And now we have to figure out who served the shortest. So when I was reading through here, we had John Rutledge, who served 1. Is there anyone else who served 1? Nope. So John Rutledge served the shortest term of 1 year. Hey, Bella. Okay, I'm going to turn the page. And it looks like we're going to flip back and forth for a bit, so bear with us. What is the median number of years these Chief Justices have served on the Supreme Court? Explain how you found the median and what happens in the terms of data. So remember that median means middle. Okay? So what we need to do is we need to take all the numbers that are in that center column, number of years, right here, and we need to list them from least to greatest so we can find the median. So I'll help us out if we all just be on page 204, and we're going to list off these numbers right here. I see the smallest was 1. You might want to write way over here because we have a long line to go. I don't see any 2s. Any 3s? No. I see a 4. I see a 5. I see a 6. I see 7. I see 8. I see 2 9s. I don't see a 10. I see 2 11s. I don't see a 12. I don't see 13. I see 1 14. I don't see a 15. I see a 16. I see 17. I don't see an 18. I see a 19. I see a 22. 28. And 34. Let me double check. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 Supreme Court justices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Perfect. Okay, so now we need to find the middle. So you're going to cross off 1 from the left, cross off 1 from the right. You're going to keep doing this until you find the middle. So we found the middle, and it will be 11. I put the data in order to find the median of 11. Okay. Make a box and whisker plot of the years the justice served. Describe the shape of the distribution and how the median and the URI relate to the box plot. Well, box plots, you can't really describe the shape of the distribution, and neither does it describe that in their answer. But remember, for box plots, we need our min, our quartile 1, our quartile 2, which is our median, our quartile 3, and our max. So our minimum is 1. Our max is 34. So this is our minimum, our smallest, and our maximum. Your median is quartile 2, which is 11. Okay, so now I need to find my quartile 1, which is the number that is the median of the bottom half. So I'm going to cross off, cross off, cross off, cross off, cross off, cross off. So I have 3 crossed off over here and 3 crossed off over there. So my middle number is between 6 and 7. So the number that's between 6 and 7, right in the middle, is 6.5. And now I have to do the same thing over here. I have to find my middle number. So I'm going to cross off, cross off, cross off, cross off, cross off, cross off. I have to find the middle number of 17 and 18. So what number is in the middle of 17 and 18? Or 17 and 19? It's 18. So now we can do our box and whisker plot using these numbers here. So I'm going to count maybe by 2s. So 0, 2, 4, 6, 8, 10. Thank you, Aiden. 12, 14, 16, 18, 20, 22, 24, 26, 28. We have to go all the way up to 34. 30, 32, 34. So make a number line and go all the way up to 34. Okay, so we're going to put a dot. Our minimum gets a dot, so put a dot at 1. That's right between 0 and 2. Put a dot at 34. So your minimum and maximum gets a dot. Then your quartiles get a line. So 6.5, we're going to put a line. It's right after 6. Don't put it in between 6 and 8, because the middle of 6 and 8 is 7. And we need 1 at 11. So in between 10 and 12. And at 18. Now connect your lines so it makes a box. And then connect your whiskers. And that is your box and whisker plot. Okay, is the median halfway between the least and the most number of years served? Why or why not? So the halfway point between 1 and 34, okay? So if I want to find halfway between 1 and 34, don't even think about this data up here. If you listed all the numbers between 1 and 34, would 11 be the halfway point? And I know right away the answer is no, because if I was at 11, I moved 11 spaces, right? So if I was on a number line and I moved 11, if I move 11 more spaces, because this is if I went 11 this way, I'd have to go 11 this way. I'm at 22. So 11 is not halfway between 1 and 34, but it is half the data. Okay, moving on to the next one. It says, a broadband company timed how long it took to download 234 4-minute songs on a dial-up connection. I bet they're using LimeWire. Ask your parents what LimeWire is. They'll know. To dial up 4-minute songs on dial-up connection. Oh my gosh, look at dial-up connection. Read this to your parents. They will get a huge laugh out of it. And then ask about LimeWire afterwards. Your parents will find it hilarious. This whole thing is hilarious. A broadband company timed how long it took to download 232 4-minute songs on a dial-up connection. The dot plot below shows their results. What can you observe about the download times from the dot plot? So most songs are between this area here, right? The downloading speed is between here. So it's going to take anywhere from our smallest time is about 5 to our most time is about 17 to download a song. It will take anywhere from 5 to 17 minutes to download a song. This is so true. If you lived in the days of dial-up and LimeWire, you would totally know this. Is it easy to tell whether or not 12.5 minutes is in the top quarter of the downloading times? So 12.5 would be about right here, okay? So is this in the top quarter? I would say yes, because I think our halfway point would be somewhere over here, but it says you cannot easily tell. This is what your answer is. You cannot easily tell with the dot plot. That's what you want you to write down. You cannot, one word, easily tell with a dot plot. I'm going to take a picture of this real quick. I find this question so funny. Oh, I almost sang a song. Okay. Posted that on Facebook because I find this question so funny. If you were in class, I'd show you all, show you what LimeWire meant, and I'll dial up and. Okay, the box plot of the data below is shown. Now answer the parts of A, B above using the dot plot. So the first question was, what can you observe about the download time from the dot plot? So what can we see by looking at this instead? Well, I'm going to write, oops, what is going on? My mouse is like 20 feet away from me, and my computer's doing crazy things. Okay, I'm going to write right here. So I'm going to write A on this side. So A on page 204 said, what can you observe about the downloaded times from the dot plot? So we're going to write A right here, and we can write about half the times. So here's your quartile 2. This is halfway point. So about half the songs download in less than 10 minutes. But remember, our minimum is 5, but more than 5. Here's your halfway point. So the other half download in more than 10, but less than 17. So we can see that with our dot plot, and I'll give you a second to fill that in. Those are all your Classcraft messages. See, for the people that send me Classcraft messages, if I'm not on my computer, all your Classcraft messages that you sent 23 minutes ago is just now coming to my phone. So it takes a while for me to respond sometimes, and that's why. Okay, so for B, question number B, letter B on page 204 said, can you easily tell whether 12.5 minutes is in the top quarter? So 12.5 is way over here. This is your top quarter. So all of this is the top quarter, right? So is 12.5 in that top quarter? Yes, it's easily to tell. So a box plot, made it easier to tell that information. So it says, what are the advantages of using a dot plot? Well, the reason why this dot plot is so much better to use than the dot plot on the page 204 is because there's tons of data. So it helps when there's lots of data. So with lots of data, the dots in a dot plot overlap. And while you can see general patterns, comma, it is hard to really get anything quantifiable, which means you can't really get anything out of the data. Okay. We're going to do one more question. We're going to skip the exercises because that's supposed to be done with a partner anyways, and then we'll go on the exit ticket and we'll be done for the day. So my plan is 16 today, 17 tomorrow, 18 Friday. That means Monday would be 19, next Wednesday would be 20, Thursday would be 21, and then we're done with the book, done with math, done with school. And that is the last day of school that we were supposed to have anyways, which was June 4th. So that works out perfectly. Perfect. Okay, Molly presented the box plots below to argue that using a dial-up connection would be better than using a broadband connection. She argued that the dial-up connection seemed to have less variability around the median, even though the overall range seems to be about the same for the downloading time using broadband. What would you say? Well, let me read this again because I wasn't paying attention. Molly presented the box plots below to argue that using dial-up connection would be better than using broadband. Dial-up, broadband. This is dial-up, this is broadband because it says that right here. Dial-up, broadband. She argued that dial-up connections to seem have less variability. So look at this, shows variability is the difference of data. So this data goes anywhere from 1.5 to 7. So this takes, and look at this, dial-up is in minutes. This looks super good, right? But this is in minutes. This is in seconds. She's saying dial-up is better to use because there's less variability. So the numbers are closer together. Look at the box is smaller. We can tell that they're closer together. Seem to have less variability around the median, even though the overall range seems to be about the same. What would you say? So would you rather wait minutes to download a song on dial-up or seconds to download a song on broadband? So she's clearly incorrect, right? That the dial-up, yes, it has less variability. So we're going to write this. She is correct that dial-up has less variability, but broadband takes seconds to download a song compared to dial-up that takes minutes. So I would rather have broadband, which is kind of like a Wi-Fi. It was the first kind of like Wi-Fi coming out after dial-up. So I would rather download music on broadband because it takes seconds to download a song. The longest song took 7.5 seconds to download. Dial-up, the shortest amount of time you're going to have is about 5 minutes. Okay, does that make sense? So she is correct that there's less variability, there's less differences, changes, but we would rather take a few seconds to download our songs than a few minutes. I mean, you're going to ask your parents about LimeWire and dial-up, okay? We are going to turn to page 209, our exit ticket. And this is what we're going to do real quick before we get offline. So 209. If your dad is the IT guy, he might know more information about it. Okay. Data on the number of pets per family for students in the 6th grade class are summarized in the data plot below. The number of pets. So I can see that right here. I hate how high they put these up. We'll use this sheet paper. So I can see that my minimum amount of pets, if I go straight down, we shouldn't have a half of a number, right? So this should go straight down. It should hit really at 1 or 0, which it doesn't. So for some reason, someone has half a pet. My paper not straight? Maybe it's my paper. Maybe my paper's not straight, guys, because it shows that someone has half a pet. That doesn't make sense. Okay. If I go straight down, it's 1. So this, if I go straight down with this, we're at 1. Woo! Someone doesn't have half a pet. We don't have to call the police. That's perfect. So this, our minimum is at 1. This is our minimum. Our maximum I really wonder what you guys think sometimes about the stuff I say on YouTube because I can't see your reaction. Our maximum is right here, and this number is 12. This is our max. Someone has 12 pets. Holy cow, they could almost open a zoo. So this is our quartile 1. This is our quartile 2. This is our quartile 3. Okay? Those are our 5 numbers we needed. Can you tell how many families have 2 pets? No, we cannot tell because we are using a box plot, so we cannot tell. You cannot tell from the box plot, period. You can only know that the Q1 is 2 pets. We don't know how many people have 2 pets, but our quartile 1, our middle number of the lower data, is at 2 pets. Given the box plot above, which of the following statements are true? If the statement is false, modify it to make it a statement true. Every family has at least 1 pet. Well, in this data, our lowest number is 1. They could have picked 0 and they didn't. So in this 6th grade class, every person picked 1. The only person who has less than 1 would be 0, and no one picked that. So this is true because our lowest number is 1. Okay? About 1/4 of the families have 6 or more pets. So remember, each one of these is a 4th. So 1/4 would be this data right here is 1/4. So does 1/4 of the family have 6 or more pets? Well, if I go down to my quartile 3, it's right at 6. So this is also true. So this 1/4, this right here is 1/4. This right here would be another 4th. This right here is 1/4 of the data, and this right here is 1/4 of the data. And when you add that up, we have 1 whole. Most families have 3 pets. Do we know that for sure? No. That's just where our median is, our middle number. So this one would, letter C would be false. Our median is 3 pets. That's true. We don't know how many of each had. About half the families have 2 or fewer pets. So here's halfway point, right? Because a 4th plus a 4th is a half, or quartile 2 tells me a half. So this, maybe I should do in red or purple. This data right here is a 4th plus a 4. Oh, sorry. This data right here is a 4th plus a 4, so this is a half. So half the amount of people have 2 or fewer pets. So if you took this straight down, it's at 3. So is that true? This is false. And we would write about half of the families have 3 or fewer pets, period. About 3/4 of the family have 2 or more pets. So we need 3/4 and we need more. So more is on the right-hand side. So this is 1/4, 2/4, 3/4. So if I go straight down right here, we have 1, this is 1/4, 2/4, 3/4. So 3/4 have more than 2 pets. So this is true. Okay, so tomorrow we're going to do lesson 17. Tomorrow is Wednesday. Nope, that's a lie. Tomorrow is Thursday. So Thursday, tomorrow, we're doing lesson 17. Friday, we're doing lesson 18. Okay? We will see you tomorrow. If you have any questions, let me know. And I will talk to you all tomorrow. Bye.